Okay. That's okay. Yeah. Please confirm you can see my screen. Please confirm you can see my screen.
Yes.
Okay, so this is the Nakuja Airframe Onboarding. This is the one in many onboarding videos. We'll try and cover most things today. So in the Nakuja, what's the Airframe team? The Airframe, as you have heard, we basically build the fuselage of the rocket. This is the body, and how do we do it? So we have some softwares where we use to build it. So we usually use Autodesk Inventor. So we'll update it to 2022 and Fusion. This will be used to build the mechanical structure. We have OpenRocket and we have GitHub. So our design phase starts on paper. So you design the initial parameters that are needed by the rocket. For instance, as you have been told, N3 will be going to 2 kilometers. So that is one of our first parameters. So we try and see what type of rocket we can build. So there are many designs. We try and look at what are some of the designs we can implement. Then we design it in OpenRocket first. Then after designing it in OpenRocket, we now design the actual rocket in the Autodesk Inventor. In OpenRocket, you can be able to do basic simulations, not so basic, they are moderate. After Autodesk Inventor, you can be able to do CFD using Fusion, and all this is collaborated using GitHub. So just progress where we are from. So this is the N1, as you can see on this part. These were the first designs. Then we moved to this design, but this design was, I think, was able to do one test run. But you'll see further where we have the actual N1 rocket. So this rocket was made of PLA. We didn't have a pyrotechnic. We had a servo ejected mechanism for recovery. Then we had 3 fins and we had a circular launch lug. So there was no pyrotechnic. So from N1 we had an improvement to use pyrotechnic ejection or piston ejection, and also use nylon parachute. Because current in this rocket we are using polythene parachutes, yes. Then on the N2, this is N2 now. So for the N2 rocket, we were able to build it using fiberglass. As you can see here, some of the students building the rockets, laying the fibers. So this was the N2 rocket. We built it using fiberglass, and here were. So this is where we start. We build the body tube. Then this place is where they build the fins. So the fins are laid on a perfectly flat surface so that you can be able to get the fins. Then after getting the fins, we cut them into the required dimensions and we attach them to the fins. As you can see here, we are now attaching the fins to the rocket. So this was also N2. So this was one of the rockets called Pekera. I think you'll be able to see this was Pekera. If you can see here, this is Tana, and I think Galana. This was a spare for Pekera. So for Pekera, the important feature of this rocket, it was using it had a roll control where we had canard fins on top. So instead of having the tail fins at the bottom, we had the tail fins and the canard fins at the top. Then here are students assembling some part of the rocket during the travel to the launch site. So for N2 improvements, what we are doing, we get a better pyrotechnic parachute ejection, we get a better piston ejection mechanism, and also we are looking into using the an aluminum fuselage for the rocket. So we'll be, I think Innocent will lead you in. If you don't know how to use a lathe, he might help you on using it. So we might intend to use the aluminum fuselage. So if it is possible, we'll fabricate our body using aluminum. If it's not possible, we'll fabricate it using fiberglass. So here are some of the designs that we hope to have on N3. So this is a New Glenn rocket by, which company is this? I've forgotten its name. Then this is the Starship. So this this is the New Glenn. This is the Starship, and this is the Falcon rocket. So these two are from SpaceX. Then this is from the Jeff Bezos company. So you can have an idea on how we can build a prototype of this so that we can be able to build awesome rockets. So this is N3 development. As you can see, apogee, this was the first simulation. Apogee of around, we want to achieve around 2 kilometers. So this was, this design was incorporating Falcon and also the, what's it called? This booster, yes. So these are just some of the photos of the development. This was during N1. So this is the actual rocket that flew during N1. It's here. Then these are some of the students have gone to Malindi. Then here is after flying N2 rocket. Some of the students had gone to the Space Expo. So reference, I need to change this to N3. So we'll have a look at the onboarding for N3. Let me stop sharing this tab. Just before I stop sharing this tab, any point of concern or any questions still there? Any questions still there? Okay. Can you be able to see my screen?
Yes.
So this is for N3. So this is the repository for N3. This will contain all the things we'll do. So first, for this is onboarding. We'll have a look at this onboarding document. So you need to, this information will be given, or you can have a look at it. So you need to have a familiarize with the Nakuja project website. Later on, you see you need to send your profiles so that they can be updated on this website. You also, I hope everyone has been able to join Nakuja project or will be able to join Nakuja project organization by the end of the week. Then this is a blog post. I hope that everyone will be able to post at least one blog post during the attachment period. Also, this is our YouTube channel, Instagram, and Twitter. So we are using GitHub. You can check out GitHub for students, where there is an educational pack. You can be able to get more features from GitHub. Then you have an Autodesk for students, where you can be able to get the softwares for free, given the students license. So the team leader is Dr. Aoki Shohei. This is his reference. Then we have Destiny. This is the Airframe subgroup leader. Currently, he's not around, so we are stepping in for him. Then we also have, before your first day, you need to do no, there is no onboarding document. There is no requirement before the first day, just getting familiarized on how Nakuja works. Then on the first day, there is airframe orientation. Then you need to attend the airframe orientation and take an oath of office. Hope everyone will be able to do so. After that, you need to call or text someone, your buddy, who you will work close with. Then you will be given the credentials for the PCs at iPeak. So this will be used for simulations, and also if you have some works on 3D printing, you will be able to use the personal computers at iPeak. You can contact our technologist, Mr. Ben Maniafu. He will be able to assist you on this. Also, you need to connect to Airframe communication channels. This is Discord, WhatsApp, Scrapbox, and blog post. So also sign into various platforms. So I hope by the end of today or tomorrow, you will be able to join a Discord. You have already joined Discord and WhatsApp, so you'll be able to join Scrapbox and blog post, and also join GitHub organization. Then the second day, info will be sent to your email. Also check to this info will be pertaining the weekly meetings on Airframe. So after the meeting, please share your email addresses with me so that we can be able to set up the weekly meetings. Then double check you have access to all Airframe platforms. Then attend the Airframe weekly meeting and make sure you have a Slack, a Discord avatar, and a Google avatar. This is the pictures that people can be able to see you publicly. During the first week, you have been taken through the tour for the facilities. I hope you'll be able to set up a GitHub account. Also visit the workshop area because we'll be having new CNC machines, and also visit where we are fabricating and see the fiberglass fabrication for N2. Then I think you've met your director. Then you need to submit bio and submit a picture for the Nakuja website. The instructions are here on what to do, and they also enable members to show your profile on GitHub. Here are the instructions. Then during your first month, I hope all of you will be able to at least design and fabricate at least one subsystem of Airframe. This will be in consultation with the engineering team. Then you will be able to schedule a virtual tea with at least two co-workers, and also complete the mandatory online trainings. These are for people who don't know how to work with Inventor and a simulation analysis. So we need to add the simulation analysis here. Just a moment. We need to add. Let me just first Slack. This one needs to be Discord. Then also on the simulation analysis, where is it? some analysis into brackets CFD. This is computational fluid dynamics using Autodesk CFD, or the other CFD is called what? The other tool. Yeah.
You said Vision 360.
No, there is another one. There is another one. There is another one. Just
The workbench.
ANSYS. Yes, ANSYS. 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 Sorry, ANSYS. 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 Also, you need to be able to do a simulation on .com. So .com, let me. For .com, you'll be able to search it on GitHub, and it will be able to. .com is a Fortran program that helps to do simulations. Then write at least write one blog post for the Nakuja. You can check out more information here. So on the software stack, as you have known, we'll be using initial designs will be on OpenRocket. So we'll be using v22.02. This is in beta. The fully supported version is v15. So you can have both of them, v15 and v22. Then you need to have Autodesk Inventor 2022 and also Fusion. Then for Fluid, you'll be able to get CFD 2022, Fusion, and also have a look at ANSYS and .com. Is that okay? Any questions on that? Any questions? Innocent, any questions?
Okay, I have a question.
Yes?
Do we have to download all those softwares?
It is highly recommended.
Okay, I have a problem because I downloaded the Autodesk, both Inventor and AutoCAD.
Yes.
Using the student license, and it expired this year, so I'm not sure if I can get it again.
I think you can be able to renew it.
Okay.
Yes.
Thank you.
Anne, any questions?
I'm good. I'm good so far.
Samti, any questions?
No questions.
Okay. So on the progress, I need you to do this is a progress for N1, but we will be changing it. So I need you to write basic tutorials on what to do. For instance, if we decide on first, you can pick up designing a rocket using Open Rocket. The second one can be designing it using Autodesk Inventor. The third one can be simulations. Then the fourth one can be fabrication. So for the fabrication, if we'll be using aluminum, I will need, let's say, you guys to do a layout on when someone is able to pick the design files, they can be able to produce or reproduce that part. So as you can see here is just a simple process on what we did on N1 on how to reproduce the part, so you can be able to reproduce the whole rocket using this file. So these are just progress on what we will be doing. For instance, we were doing parachute test. So you can be able to see all the parachute tests here. So this was the first parachute test. If you go in, you can be able to see what happened during this test, some pictures, problem and modifications. For CFD, you can be able to document the process on doing CFD. So this has been documented. What you need to do, probably just change a few parameters here and there, run the simulation, and you'll be able to get the results. So most of the things have been done. We will be just continuing from there. That is okay on progress.
Yes.
Also on research, you can put N1 fabrication, or if you are intending to write any research paper, you can be able to document it here. We will be able to help you document the research paper. This is just an example of N1 fabrication. This did not qualify for SRI, so we still just have it here as a research. So if you do, let's say if you are doing a research for piston ejection on how to optimize it, we can be able to have it here on piston ejection. Is that okay? So any question? I think the onboarding is over. So I will just like to return it back to you. Do you have any questions or any point of concern? We'll start with Samti.
Okay, that's a lot of information to process to begin with, but for the moment I don't have questions.
Okay. So I think this information, you can be able to have a look at it during the week, as you will see, because you have the link, so you can be able to go have a look at it during the week. Is that okay?
That's okay.
Mwadime?
I have no questions, but just one. How do we proceed from here? Like, do we start meeting tomorrow at IPIC, or do we have time to look at these onboarding documents? What is the direction that we take from here? That's my question.
Tomorrow we'll have another onboarding session on OpenRocket. So today, what you do tomorrow is probably familiarize yourself with OpenRocket. This week we'll try and just cover. We'll just try and teach you some basics, some few things here and there, so that you can be able to start on your own next week. Is that okay?
Yeah.
Okay. Karithi?
I think you just answered my question. I was about to ask, from what you've told us, first day and the second day, I'm only seeing open a GitHub account, log into Discord. So I wanted to ask if that's all I'll be doing this week, or there is any other, informative thing that we'll have to do this week. But I think you've responded to that.
Yes. So we'll start with OpenRocket. We'll just 20 minutes, let's say a time like this. Then we'll move to parachute ejection, where you will be taught on how to design the ejectors. Also, that will be in reference to recovery team. And also on the third one and the last one, you'd be taught how to design, or how to design the platform, or how it was designed, so that you have a basic idea, so that you can be able to create a plan at the as Dr. Oke had told you, you need to create your own plan. So we will try we can do it on Wednesday, on Thursday or Friday. We create a plan for Nakuja, then we start implementing it next week. Is that okay?
Okay. I have another concern of a question.
Yes.
Okay. So okay, we say that we already have the rocket body in place, right?
The
The body is already there.
yes, yes.
So then, are we allowed to modify the body or make another body as part? So we'll have a meeting with the other teams, and also the two N1 and N2. Maybe their weaknesses was on how the body was made, the dimensions of the body. So are we allowed to make modifications on the existing bodies as per the issues that the previous teams under Airframe might have had?
Yes, you will have access to the design files and the actual file for the rocket. No, the actual rocket. That rocket will not be reused. You will start from somewhere. You will start from, for instance, when you are going to 2 kilometers, we expect that our diameter will increase and our length will increase. Those are things we need to know. The propulsion team will suggest an optimum diameter for their motor. Then we'll start from there. We'll start our simulations from that optimum point. So we will build from what the N2 team has done. Yes.
Okay, thank you.
Any other questions? I think then we can close a meeting. We can close our onboarding session there. So I hope everyone